1, 2, 3. The record is now on. Is the screen sharing still here? Okay, so here we are. So fire away, Napat.
If you look at the grid number 1, 2, or 3,
Okay.
in typical, do we treat the beam as the continuous beam from the column at the grid Gaukai Khokai?
Oh, you mean this one, right? The beam in line core, right?
No. On the grid number 1 and 2.
This one?
Yes.
The thing is, this beam, because if it's a steel structure, we always need to have the frame to resist the load, the lateral load in both X and Y direction. So whether you like it or not, this shall be part of the frame. So that means, yes, you can say it's a continuous or not, because let's say if you look at the frame in grid number 1 and 2, for example, I believe this is the treatment that you are going to, Ajahn Suthai, you're going to say you must do. So you can draw it like this. And that's going to be your truss. That's going to be your floor. It becomes part of the frame. You have something like this, perhaps. Right? So I suppose this will become part of the frame. And I think from the drawing, where is it? Here. This is the stairs, and you may have the steel beam as well. So yeah, but the problem with this is that this becomes the more critical section, correct? Because let's say if this is, let's listen carefully, if this is the frame that looks like this, where's the note? Okay. If you are going to make the frame like that, this one will be less critical, say, than this one, okay? So it's gone into the straight line mode. Oh, geez, what is this? Okay, so let's say this picture is done incorrectly because of this straight line thingy. Okay, so your truss looks like that. So essentially, this we're talking about this frame right here. So the point is, if we design this thing and this survives, why do we need these columns? Right? Because this configuration is not available throughout your structure. So whether you like it or not, this becomes the more critical frame that you need to study, which is that you need to design, I'm sorry, which is here in grid number 4, 5, and 6. So you don't really need to be concerned about, you know, the continuity here, because you need to find a way to design these frames in grid number 4, 5, and 6 and make them survive, which is essentially this one that we are looking at, right? If this one survives, we don't need to have the columns. You understand what I'm trying to say? Because you have to design something like this too. And if you can make sure that the structure like this survives, this guy, you know, you don't need to consider this as part of your design. It just becomes accessory where you design for, you know, maybe this as a simple beam, this as a typical small column, and so on and so.
I just worry about the flooring right next to the stair.
Why? Now, let's say because this project is small and I don't wish you to do a lot of work. In typical, because this is half, you can design this as another simple beam if you wish. Okay. And one more thing, keep in mind that generally, I should maybe write this to you somewhere. This beam is not at the same level as the floor. Because now it's going to be some fun to draw this. When you look at the stairs, that's let's say this is the grid line. What grid line is this? This is grid line number 2. Okay, you say that that's grid number 2. It's my number 2. So you have the landing somewhat around here. And that is your grid line number 3, right? Oops, yeah, I say 3, but I wrote down 1. But for the beam in grid line number 1, let's take a look at that. So that's up. So that means your stair is coming down like this, right? And then down to another level with a landing, perhaps. Then this one goes down to the ground floor. So this is your grid number 1. And when I draw the side view, you see right away that, okay, your beam is going to be here in grid number 2. You have the floor. And then that is grid number 3. But then the stair is going to come down like that. So at least this beam on grid number 1 is a standalone beam because you don't have any continuity from anywhere, right, Napat? Stair is a tricky business, and that's why you need to have the columns here mainly to support the stairs. You know, otherwise, no way to construct it because the landing here is always on the different level. Otherwise, why do we have the stairs, right? Well, actually, that's down. So I think that I drew the wrong picture. The stair connected to the second floor is supposed to be on this, maybe. Yeah. So you need to swap that. But anyway, you get the idea. So I would not design this beam as a continuous beam. It has to be the simple beam. Okay, so this better be a simple beam here. So that means in reality, you can only have a frame like this in grid number 2 and 3, and then 7 and 8, right? Not many. Okay, so now I think perhaps for ease of your work, I would suggest that you don't need to do the alternative. You can just, you don't need to have this beam. So you just design this beam, and this beam will be fully braced by the floor. Okay, so you go on and work your load and try to submit the. I asked you to submit the criteria for the floor today, but if you want to submit the floor, you can do it next week, but as well. This week the roof will be closed, so no more for check. Now you can go on. Okay, now when you're going to select the floor, this beam will support the floor in this area, correct? Yeah, like this brown area. It becomes the area that your beam has to support. And when you look at the floor itself, now the floor system becomes the system screen. with the plank is going to be 4.5 meters long. Okay. And after you have checked your load, it's going to be the dead load from the floor. Correct. And then the live load. I shouldn't say floor, sorry. Finishing. The finishing you use, of course, nobody is going to leave on the PO hollow core concrete. All right. It's going to have to be some finishing on it, whether the laminated floor, the lanolin, the maybe granite, wow, or marble, wow. Marble is very heavy, you know. It's like, if I remember correctly, marble is going to cost you 200 kilograms per square meter, because you need to lay down some sand and some stuff before you can actually put marble on the system. For granite, it's going to be close to 100. So you have the weight of the finishing. I say, because we have only 2-story. So let's go to the see the cross section. Like here. So chances are you're not, if the building is like this, you're not going to have anything, maybe nothing underneath the floor. Let's say if you are in the building that has more than 1 story like this, you may expect your floor system to also support the piping system, the conduits, the ceiling. Okay, everybody has ceiling, right? And I can show you, that's the ceiling in my house. Okay, everybody has ceiling, and the ceiling will have to be supported by structure of the 2nd floor, right? And you may or may not include the ceiling weight in your structure, but that's not heavy. But typically, expect the load from piping, conduits. Right? You have the system for the air conditioning, the piping system for your toilet and sanitation, and perhaps the conduits for all the wires, because we now have the internet connection and so on. And ceiling. You may wish to, did I spell that correctly? How do you spell ceiling? I-E or E-I?
EI.
EI, right? Thank you. 1 L. Yeah, that looks good. So that's gotta be it. So you can expect to add this load into your floor system. It comes underneath. But for this, you may not have to because of the structure. But if you really wish this design project to be something that you can always refer to, you can just add this. Okay, this is real, ladies and gentlemen. This is real work. So this, I can say with that, finishing. I use the green one. What's the color? Try to be with the same color. Sorry for going up and down. I think I missed it. No. Okay, actually I swapped the color, but it's fine. So doesn't matter. You really shouldn't do this. Going up and down, I mean. Oh, geez. Sorry. Okay, here we are. And piping and conduits plus the ceiling. And so on. So you may need to do this. And then plus live load. When you add this up, you have every load except the weight of the floor. Okay? Every load except the weight of the floor we call this thing superimpose load. It's the load that is imposed on the floor. And generally, when you go to the catalog, they will say that you select the floor based on the superimposed load. So let me stop the share here, and I will share the screen with this picture. Okay, I have posted this one on our Facebook group already. Generally, you see that annotate spotlight. Okay, you see, save is super. Oh, I thought that I could. Where is the? Okay. See, superimpose load. Now you are going to pick the slab type to say on your drawing. So you see, you need to know your superimposed load, which is in kilogram per square meter, you see. And now you need to know how long your slab is going to be. So how do I, okay. So here we are, you have a 4.5 meter span length, and you find that actually this guy can take the superimposed load only 261. So this one may not work, so you move on to the next one. And you see 4.5, you have more load now because you have different details here. Okay, and this is how you picked it. And after you pick it, you pick your floor type, say 4.5, you see we have like 500. You will know the weight of this floor because it says here, slab self weight 133. Okay, and I don't I'm not sure if they okay, here slab weight, because that's self weight. You need to include the concrete topping as well. So you will be able to pick the weight of the floor from this table, but you have to select the floor first. Okay. Any question? You know, last year it took really a long time, or 2 years ago, before they could understand what is superimposed service load is. This is the load, anything that the floor has to carry except the floor itself. So you select the floor here based on every kind of load that the floor has to carry except its own weight. And by selecting this, you know the weight of the floor from here. So when you design the beam, now you must add this in addition to the superimposed load that you use to select the floor. Okay?
Yes, excuse me.
Yes, please.
Since it says that save superimposed service load, so that it means that the safety of factor is already accounted, or not?
That is a very good question, but this is the load side. The part factor of safety is on the resistance side. All right. You mean the floor itself?
Yes.
I should say yes. It has to be. It has to be. But this is like a concrete business, so I'm not sure what factor of safety they use to give you this. But they must. Okay. Good question. But again, everything is a service load. So when we calculate the beam, we must don't forget the factor of safety on the resistance side that we are going to calculate. Okay, so let me recap again. Ooh, what's this? And oh, geez, sorry. Okay, we're back in business. Okay, I think I need to write a note. So for the pick the floor, for type by using one, its span length, which is, I'm not going to say, but it's 4.5 meters. Okay. Second, its span length. So sorry, no apostrophe. Its span length and superimpose load. So, which means everything the floor has to carry. So after this, after the floor is selected, not the weight, okay, let's just make it shorter. Its weight is known. As a result, W on the beam is weight superimpose load plus the floor weight. Okay, that's clear enough? And let's say how many beams you want to design. Apparently you have to design this one. This one, if you want, it's okay. It's a shorter one. I try to ask you to design at least 1 or 2 beams, maybe. But this one is going to be important. But say, because we are going to put the floor, generally, let me tell you this, but you don't have to do it here, okay? Generally, we're going to put the floor in this direction, right, to reduce the moment. Because most of the weight will travel directly onto this cantilever portion. See, the weight of the floor will go on directly here, not on this beam and then go back here. That, if you put the floor in this direction to be supported by this beam, that means the point load for the cantilever portion is going to be huge. So the best way to minimize the load is just put the floor in this direction. That's one thing. A second thing you must know is that in the real world, this is the corridor that will be exposed to, say, the atmosphere. And therefore, you have rain outside. It's going to rain around here and it's going to receive some rain. Generally, we don't use the precast concrete for exposed weather like this because you're going to have a moisture and leaking problem. Generally, you will use the cast in place concrete here, okay? But for the practical purpose of the class, I will simplify it. But keep in mind that, when you work in the real world, we don't do that because it's going to leak down to the floor below and it's going to look ugly. For example, your house. the first floor is never, the first floor is still fine, but sometimes it's not. The first floor and the roof, we don't use precast concrete because of water problem like this. Okay, keep that in mind. It's like my house, for example, the second floor is the precast, but the first floor and the roof, they are cast in place concrete to prevent water problem. Just a little knowledge you can pick up from the class, okay? And now let's say I will summarize this again, but now you can work on the load on the beam, and please, I think you can design one column, that is this one. Okay, let's decide just one. Or you want two? Actually, two is better because the load is quite different. Okay, so this column, you see, the load diagram will be that. I wish you to be familiar with the load diagram. That's why I want you to design one column. Okay, column. This guy will go on to support the roof. Okay. So, and keep in mind that your roof is not a simple beam, you know, that this portion here is a cantilever. You may use the tributary area to summarize the load from the roof. Tributary area is fine. And then you have the second floor coming in. Let's call, we're not going to call this the first floor, right? It's the second floor and then the ground floor. Okay, so it's second floor. So this column here, now we'll have the additional load from this. So this load is the roof plus the second floor. Okay, and this part is what we call the, you know, column diagram. That you something that you should understand. And generally, we usually have bigger buildings than this one. So anyway, since we are not going to have that very complicated problem, and it's only 2 stories, so we are not going to change the size of the column, because we in typical design, the column size is changed every 2 floors. And we only have 2 floors, so it's going to be crazy to change the size of the column. So you are going to design this. So we are going to design this. Okay, and then we are going to design base plate here as well. So because we are going to design just one column, let's do it 2 in the plan. Okay, so let's design this one and then that one. You may call this one C1 and then C2. Okay, and if you what you can do and submit for overview next time is the column load. Okay, this one, like this column load diagram. Basically this one, this is it, column load diagram, just to show the load from the roof and then from the second floor for column C1 and then C2. Okay, and also check on the uniform load acting on the beam here. Say your typical B1 here. Okay. This guy, it's worth checking because this beam, you see, can you see this beam? Are you with me? So quiet. Can you see this beam? Are you with me?
Yes.
This beam will carry half the floor, but it will carry the wall. Okay. Actually, we have 3 classrooms, so you may include the wall on this beam, so it's going to be heavy. So now you have 3 loading criteria for this beam. Okay, this beam, half the floor and the wall. This beam is just the full floor, no wall. This beam is full floor, you know what I mean? 4.5 meters, but I'm not sure. Can I see the? It's very hard to see. This is what you can see from the drawing. You need to look at this symbol and go check the architectural drawings, what kind of material they use. But it's pretty hard to see from here. I don't know. So you may assume this to be the partition, the not a very half brick wall. But I say, you know, it's a classroom, so you should have something like a soundproof, maybe. So to use the partition that may not be soundproof. So you end up with this beam is going to be quite heavy because a wall, you must know this as well. Maybe you know it from RC, but that's fine. Wall. We have half brick wall and a full brick wall. Half brick wall, it means that actually they use 1 brick for the thickness. A full brick, they use two bricks. I don't understand why they call half brick. I don't understand why they call half brick a full brick. But anyway, the weight of the wall is generally given in a kilogram per square meter as well. Half brick is 180. But keep in mind that, per meter, I'm sorry. But keep in mind that this meter is for the height. So when you multiply this load with the height of the wall, you get the uniform load on the beam right away. So you check the height of the room and then you get it. The full brick is of course 360. Okay. Let's say what I do, my practice is that I would check all the loads like this and see how different they are. And I may, if they turn out not to be so much different, I can use 1 beam section for every beam that you have here. But if they turn out to be so different, I may use 2 sizes, okay? Because the load is different and we can save a little bit. But this is going to be part of the frame as well. So if not too much, you may use 1 size for ease of construction. There's nothing wrong with this. Napat, please go ahead.
On the beam that you add between the grid number 3 and number 4, can we extend that to reach the boundary of the corridor so that it helps supporting the floor?
Yeah, yes, you can in the real world, but it's gonna create a lot of trouble when you're trying to make a continuity here because you need another support here, right, to support this beam.
Okay, I see. And another question is,
let me finish this because your point is good. I say that you may not have to use this one. Okay, so let's forget it. But if you extend this, the first choice is just to use this beam to support it. Okay, but this is a steel structure, so the construction at this point may be difficult. So you have another choice to extend this beam from this right here without having the beam to support this beam here. We can also do that, but this beam will in turn become a heavy burden to this point, and therefore you're going to suffer here. Okay.
I see.
So, okay, let's go to another question.
From the building act, we have many number of the live load, but for example, the normal school in the classroom, they have their own number, and the corridor or the gym,
It's different.
yeah, different.
Yes.
Is it practical to choose the greater one so that it is easier for design?
If you are a good designer, you actually use both numbers, you know. Let's say if the difference is huge, it will not be practical in terms of economy, right? And it doesn't hurt to use two live loads at all. It just you know, another load. But it doesn't have to be school. It's up to you, you know. Enjoy, have fun. You can say this is going to be my apartment sometime.
I'm just asked for beneficial about the construction process, so that
no, because the construction process would not have anything to do with calculation.
Yeah,
you may have to select different floor, right?
If we keep it in all one spec, so the worker can be less.
True, but that's in the end. After you consider the live load, you may choose to have the same floor type. That's good. That's a point too. Yes, because let's say after you consider the corridor and you say, okay, you know, the corridor is only a tiny area, so I'm going to use the same precast that can carry more load, or the same precast that I'm going to use in the classroom, for example, that will help ease the construction process greatly. You're right. You're correct. And generally we do that. And that's because this is the small building. So I may do that too. After I consider all the load on the beam, I may in the end use one side of the beam for ease of construction. Because if I use two beams, they're going to, okay, this grid line use this one, and that grid line use another one. And procurement will be easier to just order one size. But this project is small, so it may be better to do that. But let's say if you have a huge building and the floor, the same floor plan is repeated like for 30 times, that's going to affect the budget, right? Are you guys getting this? So it's a picture that you have to look at, because this project is small. So I wouldn't mind if you say you use the same size. Let's be realistic. But if this is the 30th floor building, you may have to consider, you know, small details seriously, because it will affect the budget enormously. Okay. We are going to design for real now. So it's a phase that you are studying the load. So get it right first before you start to design. Okay. Any more questions?
How about the truss configuration? So
that's up to you.
Because we don't really know yet about which one advantage and disadvantages.
No, from this project, right?
Okay.
Don't be so serious about the configuration, saying, "Ah, my configuration is not very efficient in terms of, you know, the low tension compression, so and so." You learn. Just pick one, okay? I'm not going to kill you because you choose bad configuration or things like that. Remember that there's nothing, you can't say this design is completely wrong because, you know, it's less economical or something like that. It's not wrong. It just may good or bad. That's all. But it's not wrong as long as it is safe.
I just can't decide with no information.
Well, you have enough information. You need it's the load and the supports, right? And perhaps I don't know if you can use this information to figure out the depth of the truss. See, it's also given here. See, that's the depth available to you. And I say this is pretty small truss, 6 meters in midspan and 9 meters cantilever. So it should be okay. And the load is pretty light. Keep in mind that this cantilever is pretty large. Okay, so the force in the members here might be dominant. And one more thing, I think I'm gonna summarize here, but you can say that because we use one member to create this top chord and bottom chord, right? So you only need to say obtain the maximum force anywhere on the member. You don't have to design for everything. You just find the maximum force and design the top chord and the bottom chord, and then all these diagonal members, diagonal and vertical members. Keep in mind one thing, ladies and gentlemen, we are talking about the unbraced length already. This is a simple beam in here. So top chord is under compression, bottom chord is tension, but it's going to change because this is cantilever. So the moment becomes negative, right? So the top chord somewhere will become tension. The force will become tension, and the bottom chord, it will become compression. And keep in mind that if it's a bottom chord around here, you don't have the brace from the purlin. Be mindful of that. But if it becomes necessary, what we can do is this as well. Let's say you have the it's going to be very difficult to draw. You have purlin here. Say purlin coming in here, right, on top, on the top chord. You can extend something from the purlin to brace the bottom chord as well. So if I draw it side view, if I look at the truss from side view, you see the top chord and the bottom chord somewhere, right? And then you see the purlin. You can do this. You can extend, you can add a member from the purlin to help brace the bottom chord if you need to. Okay. Now that's time to worry about this later, but this time you make sure that all the load is correct. Okay. So that's it for me today. Is there any question? Any more question? You have to work on it before you have questions.
It is possible for purlin that doesn't paste on the joint of the truss.
It is, but this generally you will see that everywhere you go, you actually rarely see the purlins on the joint of the truss, right? That's reality. So it's not a good thing to do, but people don't care when they construct it. And I'd say it's down to, say, the quality control during construction. They don't care. They just lay down the purlins, make it easier for them. But in theoretically, the purlins should be placed here and here and here. You see that even the drawings here are bad. And you have here and here. Okay, you need to have two on top, otherwise you cannot install the roof because of the change in slope, right? This is what we do for design. But what they do, they put the purlins somewhere on the top chord. But the structure survives simply because, first, where is the load on the roof? What is the load on the roof?
Tie.
Huh?
What do you mean?
What is actually the live load on the roof? I should say live load too. Live load generally reflects the occupancy or how you are going to use your structure, right? Just like the live load in the classroom, for example. So where is live load on the roof really?
Construction worker.
Yeah, which is not there anymore, right? It's only there during construction. And after that, it's all empty. So you have the roof with no load, but we designed every member to withstand the live load, say 50 kilogram per square meter. So even the bad construction like that, the roof will not fail because the load is not there. But this doesn't mean that as engineers you say, yeah, fine, let's go ahead and do it. You know, let other people be bad, but we are gonna be sound, good, and ethical. Okay.
For the roof system, it need to consider about the weight of the truss right now.
The weight of the truss. Now you're talking. What kind of weight? What kind of load is the weight?
Material, dead load of
No,
the,
what kind of load is the weight? Point load or uniform load or anything?
point load that occur. No, the point load that you.
So the weight of the member is a point load.
Distribute.
Yeah, it's a distributed load. So generally, if the weight of each member is a uniform load, right? Ooh,
Yes.
so how can we put uniform load on the truss then?
Oh.
Oh, I don't remember if I mentioned this, but because I didn't teach, I didn't lecture the truss in structural analysis #1 anymore, right? It becomes quite interesting. How do you manage the weight of the truss? Because it's uniform, right? And truss cannot carry uniform load, right? Okay, how do you handle the weight of the truss? How do you handle the weight of the truss? It's a uniform load, right? If you put the weight of the truss in your analysis, how would you do it? A hand calculation becomes impossible, right?
Yes, yes.
Because now we're talking about the frame with the uniform load and the axial load and everything. So ignorance is a bliss here. Generally, when we design a truss, we can say omit the self weight of the truss because generally it is very, very, very small. When you talk about a truss like this, it is small. So you can say it's negligible for now. Now, let me talk further about this because this is pure knowledge to you. When you decide, when you handle the truss that becomes significantly large, or sometimes in the old days, the people didn't have enough technology to handle the steel structure because they cannot manufacture it. They cannot, say erect it properly or whatever the problem is. So they used to construct the concrete truss. You believe that? You may run into the concrete truss bridge somewhere in Thailand. You know, the old bridge in Ayutthaya, they stopped using it. Now you don't use that anymore. So when that becomes the case, or when you design a mega truss, for example, in Mecca Bang Na, you know, have you been there? In the concert hall, if you look up, it's a mega truss on top. In that case, you have to include the weight of the member. And your analysis becomes quite complicated. And you are no longer dealing with, say, the pure theoretical truss. You are dealing with the frame now. And it's pretty much like the structural analysis #2. All the members in your so-called truss will have both axial and bending moment, axial force and bending moment. Okay, that's one thing. Now, second thing, when you say you use the computer program to design your truss, and computer programs now are pretty smart, and it will give you the option to include the weight of the truss members. And some do not know this, and they go on and try to use the computer program to design a small roof like this. And they end up having bending moment in the member and they get shocked. So what is going on here? How can my truss have bending moment? Or some are not even aware of it at all. So keep in mind that if you include the weight of the truss, no matter how small it is, it will create bending moment because it's a uniform load that doesn't act through the joint. So your truss will have local bending moment the way it actually has because of the self weight. But in typical design for a roof, a small roof system like this, we are safe to say that you can neglect the self weight for the time being. Okay? See, your good questions like this will bring about more knowledge and experience for you. Good question. Like it. More, please.
About wind load. Okay. I try to find the document and role that will be satisfied to the condition. And I found that it have one factor, which is the in Thai ค่าประกอบความสำคัญของลม or efficiency of the wind load, right? It had to part which one is a limitation situation of the force, and the second one is the service. So which number we're gonna use? But the number of the
you can hold on to your horse for the wind load because that's a lateral load. Okay.
Yes.
Let's deal with the gravity load first, because I honestly do not know how Ajahn Sutat wants you to consider all the lateral load. To ask this question bluntly, to answer this question bluntly, I have to say that you have to ask him again.
Okay.
Okay, but for the future purposes, you know when the time comes. Because it's hard for me to answer that because I don't see the standard in front of me. Okay, there are two ways to consider the live load right now. First is by using the standard that you are referring to. The second is by using the good old Building Act, which simplify the wind load into just some constants that depends on the height. Okay, in real life, if it's steel structure, you should consider wind load because of the nature of the discontinuity in the members. You need to form the frame out of members. Okay, but this building is not very high, like 7 meters. Generally, we don't bother with the wind load, except some area where you may encounter a problem in real life here. It's going to be an uplift. You know, the wind comes in strong and blow up this portion of the roof. But for the time being, let's neglect this cantilever portion of the roof. Okay. So you can see that from time to time you hear the news that the roof of the many houses got blown off during the storm, because generally we don't design the roof to withstand the storm. It's just going to be huge. So let it be blown away and then we'll fix it. Okay. But anyway, that's not a good thing for engineers to say. Another problem that it's beautiful, another solution that is beautiful is that you try to build a tree around the house to prevent the wind. Okay. That's one thing. This building is not so high, so we may, in real life, we may not need to consider the wind load. And likewise, but this particular drawing is for the construction in northern part of Thailand, so they consider earthquake, I think. But in the law says that if your building is below 15 meters like this one, you don't have to consider earthquake as well. How's that? So let's say if it's concrete structure, like, because this looks like your typical house, you know, all the houses are not designed for wind load. If it's concrete, especially, okay. So let's see what Ajahn Sutat will give you on the lateral load, okay.
Excuse me.
Yes.
This might not be relevant to our course, but
No, don't worry about it.
okay. From the catalog of the tile, there is a range of the recommended slope angle of the roof, and from this drawing, it is out of that range. What tile can be open?
Tiles, okay.
Yeah.
Right. So yeah, you're right. So in that case, you're gonna have to use the roof as the slope as recommended by the tiles, because I tell you to use the roof to your liking. So this slope may not be applicable. So you may have a better depth for your truss. Yes. That recommendation is for, say, the water drainage. If you use a slope less than that, you're going to have ponding problem. The water will stay on the roof and the leaking problem will occur. So we have, if you change the tile and it requires different slope, please stick to that, okay? I heard piles instead of tiles. So I would, what? You're gonna ask me about foundation now? Okay. Is there any more question?
For the cluster storing, this is open system, right?
What do you mean open system?
No, like a part resistance, carports, or some insulation on the top.
Well, I think it should have some, at least assume to have some ceiling, right?
Okay.
Mm-hmm.
That's mean this structure is just only the force, but we need to have some ceiling or finishing over this, right?
Yeah. Would you like to say sit in a room and you see the truss, and then and it's gonna be pretty hot.
Yeah, like structure of dome or something.
Yeah, you can add the weight of the ceiling and insulation and stuff to the roof right away. Okay, you don't add it on the bottom chord just to make your life more miserable.
Okay.
Mm-hmm. Yeah, so you know we all want to live comfortably under the roof, right? But when it comes to the analysis and design, I don't want to do that. I don't want to do this. Yeah, that's a human being, huh? But I'm glad that my house has a ceiling and insulation. So you know, because funny thing is, well, it's my house, so that's not recorded. It should be on the record. Anyway, so is there any more question then? So next time you should just, if you want to, submit the column load diagram and load on the floor that you put on the beam, okay? Here, all right. And now a column load diagram that should also include the load from the roof as well, right? And now you may think, because when I say you design the truss, you omit the cantilever portion here, okay? But when you sum the load on the roof onto the column, you should include this area a little bit. Don't worry about the truss, but when you sum the load from the roof onto the column, please do try to include it. Please do include this, okay? So the tributary area should be like this, half of this distance, right? And then that much. It's, you know, the load is not significant at all. And you see, when you need to design the steel column, wow, it's going to be so small. And here. Okay. Any more questions, maybe?
I just want to know for the spacing of metal sheet, because metal sheet can long as we want, so that doesn't give the spacing for metal sheet.
You mean you're going to use the metal sheet for the roof?
Yes.
Well, I think you can find it on the internet. It's same as another tiles. I can tell you right now, but I'd rather that you find that information. You can use metal sheet. Yes, it's really light.
I already find it, but I cannot find it.
Look harder, man. Spacing for metal sheet is pretty simple. And my house use metal sheet as well, and with insulation. Because if you use metal sheet and you don't use insulation, the problem with metal sheet is that when it rains, you know, it's very, very loud. Super very loud. You can't sleep underneath it. And say, if you really want to use this as a school and you use metal sheet, when it rains, no teacher can teach. It's going to be super very loud. So I don't have the English word for it, but it's pretty much like คุณตีปี๊บตีสังกะสีอะไรอย่างเงี้ยนะครับ super very, very loud. But spacing is pretty simple. Please look harder. And if you still cannot find it, just ask me personally afterward. But I want you to try harder, because let's say if you are in the design company now, and then I say, hey, we want your work now, and say, oh, I cannot find space for metal sheet. They're gonna praise you a lot, right, for that. Well, come on. You can do it, man.
Excuse me.
Yep.
Let you draw it. Let you write. Don't forget live load. So in the roof system, let's do mention that the wind load will be negligible in this case, because it's not height of the building, right? But we're gonna consider like a worker of the people who work on the roof.
That is covered in the live load. That is part of the law. You have to. It's a live load.
Mm-hmm. And what about rain? When it's half rain, or we can neglect as well?
Well, rain is complicated because, say, in Thailand, we are going to use the tile with the information like one of your friends just asked. If you use the proper slope, supposedly all the rain should be drained away. So as soon as the rain hits your roof, it is drained away. So we don't consider the rain load. But for some reason, your roof cannot have the draining system that will facilitate this. You have to consider the water on the roof. It's called ponding. But I don't think we do that in Thailand. We always have the roof system that you know, has enough slope to drain the rain away, and we also make sure that we are not going to have a lot of rain accumulated with the storm drain. Have you heard of it? See, they have the draining system there. Here, it's a draining system. So all the rain will go away quickly. Good question, really interesting. You know, I remember one time I went to the company that I used to work with. As a small company. I stayed with them for the short period of time because I know them very well. So I went into the office one day and it rained heavily. The thing is, something stuck in the storm drain, you know, and heavy rain. So water from the canopy area outside, it just got, you know, it came into the office area. It flew into the office area. And inside, you know, we have a waterfall in the staircase, something like that. So that because the something got stuck in the storm drain, so it could not really, you know, did its job. Awful. Water is an important problem in a tropical area like this. Okay. More question? It's good that this is also recorded. I think so, right? Yeah, right. Still recorded. So yeah, you can listen to this again. And now please understand that I make everything public now. So I'm not gonna post the link anymore. Okay, you can just go to the channel right away. Okay, you can access anything you want for the sake of knowledge. Any more?
Yeah. Could you describe more about the water ponding? Because for the slope of the roof that will occur, this occurrence that you mentioned, I would like to know a little bit when the rainfall will go to, for example, when the slope is greater than 0 degree, that means that it have a little bit slope, and that means the water can fall down. So is there any case that water will go to the construction or water ponding that you mentioned?
Well, generally, if you use the slope recommended by the tile manufacturers, ponding should not occur. Ponding is like you have a pond on the roof, so to speak. It is there is the formulas and consideration available in the AISC design spec. If you wish to consider ponding, I myself never look at it because I always think that, okay, we use the slope as recommended by the tiles is good enough. And the way that architects work here, they always use the roof as a slope as recommended by the manufacturer. So I suppose you may encounter a problem like that when, you know, say somebody doesn't follow the recommendations. We all do, but you may say in the future, it's like if you run into some bad construction, and there may be the case where you can see the pond on your roof, and somebody may ask you, hey, can you actually calculate whether or not that is safe with the ponding effect? You say, okay, you can investigate that by you following the specification as recommended by AISC. Okay.
Like a flat roof, right? This can be occur.
Yes. You can have a flat roof, but let's say if you are going to use the tiles, you're not going to use a flat roof. It's impossible. Nobody does that. But you can have the flat roof, but typically that's going to be the RC roof, where you can go up and have
like apartment, right? In the top.
Yeah, right. And when the roof is concrete, you're gonna have to use something different because the live load is going to be different. They expect you to use the roof. It's concrete. If it's concrete, so the live load that you are going to use for design is not going to be the same as this typical roof with tiles. And with that, keep in mind that you need to really have good draining system. Otherwise, you must include this kind of load on the design of your concrete roof. Simple as that, right?
Yeah, I see.
Because sometimes people will be crazy enough to have the garden on the roof. So you must include the weight of the garden when you design the roof. That's all. And sometimes the rich people, they like to have swimming pool on the roof as well. So that would be quite a problem because you put water in your head waiting for it to leak. Something like that, right?
Okay, if it happened, how can we fix immediately? Like
If
to find the material to close?
if the leak happens,
Yes, like swimming case.
oh, it's a terrible headache. It's an absolute terrible headache. Very, very.
Water.
Yeah, because water is the irrepressible material. You know that?
Yeah.
You cannot change its volume. So wherever there is a small crack, it will just go. So to locate where the leak occurs is extremely difficult. I have had it with my house, believe me, because of the wonderful idea of the architect to have the metal deck as part of the roof. So yeah, it takes like so many trial and errors before the leaking problem can be fixed. It's difficult. So keep in mind, better do any preemptive action to prevent leaking from happening. You can use a very thick swimming pool floor, use all kinds of insulation materials and so and so.
I see.
And use a double reinforcement, stuff like that. Because once it occurs, especially with the concrete floor, you're pretty much done. Right? Because water will go anywhere. It's irrepressible.
Excuse me. Can we change the height of the truss so that we don't have to scroll to find out the tile that match the slope angle?
Any means you like. Because if you choose this one kind of tile, you have to change the slope of the truss to match the recommendation. So you change one thing or another. You change the truss or you change the roof. Okay. It's up to you.
Okay.
All right. I think that will do today. Unless, of course, you have more questions. I don't mind. Okay, you guys have gone quiet now, so I guess that's it for today then. All right. So let me stop the record.